Alright, in this video we'll look at another technique. If I look at this guy, there's a couple things I can do. I can factor that denominator. I don't know if that's going to help me. Or I can recognize that this is very close to a form we've seen a lot. That's u prime over u du, which we know if we integrate that we get natural log of u. Alright, so what's the derivative of the denominator here? It would be 2x plus 2. Right? If I could just have a plus 2 up top, then it'd be really easy to integrate that. So that's exactly what I'm going to do with this guy. I'm going to make a plus 2. Right? But of course if I add 2, I gotta subtract 2. Right? So I just in essence I've added 0. So what I have now is 2x plus 2, which is what I want, over x squared plus 2x plus 1. That's u prime over u. That's very easy to integrate. But then I got this pesky minus 2, right? This minus 2 guy, which will mess up that now I don't have exactly the derivative up top. So I'm just going to separate him like which was one of our techniques to separate the numerator, right? So I can move him out and he can be his own rational function. So that's equivalent to 2x plus 2 over x squared plus 2x plus 1. Right, and that's what I want. Minus 2 times just 1 over x squared plus 2x plus 1. Okay, so what we've done is we've created two integrals that I think we can deal with, because this first one is just the natural log of that denominator. Right? Well, plus 1. If I take the derivative of that, it would be 1 over x squared plus 2x plus 1 times the derivative of that, which is 2x plus 2, so check. And over here, I have to figure out what to do with this guy. I can factor him if I want. That's going to help, I think. Because that I can do u-substitution with. That's essentially, I might not even need u-substitution. Right? So that's du and dx would be the same. Right? So I can, if I want to, x squared plus 2x plus 1 minus 2. And really it's just, this is u to the negative 2. Right? So the antiderivative of that would be u to the negative 1 times negative 1. So that should just give me u to the negative 1 times a negative 1, because that, when I do that, that would come down. So really it's just going to make that a plus, and then I have plus c. So I skipped a little bit of work there, so see if that makes sense. If you were to differentiate that, you should get that, right? So bring the negative 1 down, negative 2, which somehow went away. Bring the negative 1 down, you get a negative 2. And then you have x plus 1, take 1 away to the negative 2, times the derivative of what's inside, which is just 1. Okay, so that looks like it's going to work out. And by creating a special form, right, if we could see that, this problem becomes really easy. If we can see that we just had to add 2 and subtract 2, then we have a pretty easy problem to deal with, and we can clean this up if we want to. Write this as a rational function, plus 2 over x plus 1 plus c.